Hi guys, just a quick lesson on amplitude changes in our trigonometric functions. So the key points on sine and cosine real graphs are really easily displayed here. So just to remember, the sine graph starts from the origin. One period is as far as 2 pi. Cos graph starts from 1 period is 2 pi. Half period is at pi, and half period is at pi for the cosine. And we can also remember that the max is going to be 1 and the min is going to be -1, which means they've got a total amplitude of 1. Okay, and it's the same for the cos. The amplitude of y is equal to a sine x is half the vertical distance between the maximum and minimum values of the function. Okay, so the amplitude then is the absolute value of your a. So if your a was 1, your amplitude would be 1. If your a was 2, your amplitude would be 2. Okay, which would mean it would go up as far as 2 and down as far as -2 if there was nothing else being done to the x. Okay, so if a is greater than 1, if the amplitude is greater than 1, then the graph is going to stretch vertically, so it's going to get steeper. If the a is less than 1 and greater than 0, then it shrinks the graph vertically, so it's going to get smaller. And if the a is less than 0, then it's reflected in the x-axis, so it actually, your sine graph would normally go up, it starts now to go down. So if I look at these graphs down here, the first graph is the parent graph, so y is equal to sine x, so that's my red one. So I go up as far as 1, down to 0, back down to -1, and up as far as 0. That's one full period. Okay, so that's my red graph. If I look at the blue graph, it says it's 2 sine x, which means it's going to be stretched vertically. As we can see, it now goes up to a max of 2 as opposed to 1, and down to a max of -2. So it's going up 2 and down 2, so it's stretched vertically. Still is the same period, 2 pi. 1/4 sine x is the green graph, so this is compressed, so it's now going up as far as 1/4, down to 0, down as far as -1/4, up to 0, 2 pi is where it finishes, and then it repeats itself, etc. The last one there is a -3 sine x, so I know that I start at the origin, but instead of going uphill, I'm going downhill because it's now negative, and my max is going to be, my minimum, is going to be -3, and my max is going to be +3 because my amplitude is 3. And that's what I'm going to end up with. Okay, so it's the amplitude is the number in front of the sine x. It's the exact same stuff for the cos graph, so you can look at those examples. So y is equal to cos, I start from 1 and go down to 0, down to -1, back to 0, back to +1. That's one whole cycle of the cos x. If I have 3 cos x, it's going to be stretched vertically, so instead of starting at 1, it's going to start at 3, go down as far as -3, back up to 3. Half cos is now going to start at half instead of starting at 1, going to go down as far as -1/2 and back up to a half. And then the -2, instead of going down to begin with, it's going to go up, and it's going to start at -2, up to +2 and back down. Okay. The function y is equal to tan x has no amplitude, but it will still be stretched. So it will still be steeper or else compressed. So for my original, it's the red one. So I'm going to have my red graph looks like this. If I have a 5 as my number in front of the tan, then that's going to make it steeper. So you can see that this blue line gets steeper much quicker than the red one. And the green is going to go reflected about the x-axis, so it's going down the way. Okay, so sketch the graph y is equal to -2 sine x, and the domain -2 pi is to x. Where x is greater than or equal to -2 pi and less than or equal to 2 pi. So straight away I can graph this function, and I'm going to have to draw my lines, so you're going to have to bear with me. They're probably not going to be perfectly straight, but that's okay. Okay, so I'm going to mark on it the important parts. So I'm going to look at 2 pi because that's my domain. And I also need it. Let me rub that out because I forgot I needed to go to -2 pi. Okay, so I just rub out the vertical line. I'm going to rub out this one. So I now have it going as far as 2 pi and back as far as -2 pi. Pi is my halfway mark, so it's -pi and pi. Okay, it's the sine graph, and I know that my amplitude normally is 1, so this time it's going to go up as far as 2 and -2. So I can plot my points. Sine always starts at the 0, halfway it'll be back at 0, and after 2 pi it'll be back at 0. -pi it'll be down at 0, -2 pi it'll be at 0, and sine goes up the way, so at pi over 2 it's going to be at 2 because that's my max, and at 3 pi over 2 it's going to be at -2. Same for this side, the other way. That's what it would look like, but I need to remember now that I've got a 2. So it's actually going to go the reverse of that. So I should use a different colour pen, sorry. So this is blue, and this is blue, and then this one's going to be up high, and this one's going to be up high. So that's what the red ones are what it would look like, but because I've got my -2, I need to change it. So my origin is my beginning, and I'm going down because it's negative. Like so. Ah! Sorry, guys. My God. I hope your graphs are better than this. So I'm actually going up for this one as far as 2 and down as far as -2, like so. And it would just repeat. So because my domain was -2 pi to 2 pi, I had to go like that. Okay, and you would need to finish in the domain, so I don't need that extra little bit. Okay. So the red ones is what I was used to with doing an amplitude of 2, but because it's -2, I need to reflect it about the x-axis. Apologies for the mistakes. Okay, the next example, the sketch the graph y is equal to 4 cos x minus 1. So when I'm sketching the graph 4 cos x minus 1, I need to first of all look at my domain. So the last mistake I made, I didn't look at my domain. So this time I just need to go from 0 to 2 pi. So the graph I can draw can start off over here, and it's going to go like so. Okay, and it's 4 cos x, so I know that it's going to have an amplitude of 4. But I can see that it's actually also going to be a -1 transition, so it's going to move down -1. So my max is no longer going to be 4, it's going to be 3, okay? And it's no longer going to be -4, it's going to be down further one for -5, okay? And because my -1 is this section here, that's going to tell me what my center part of my graph is going to be. So -1 is going to be my center, this part here, so that should be the center of my graph. So it's the cos graph, so my cos graph normally starts at 1, so this time it's going to start at 3, so it's going to start at 3, and it's going to go down as far as -1, that's going to be where it would normally touch the x-axis, and it's going to go down as far as -5, back up to my x-axis, but this time it's my -1 because that's my center of my graph, and then back up to my 3 for my 2 pi. Okay, so I'll just quickly mark on actually my values. So this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, and then I can sketch my graph. So it would look like this. And that's it, I'm finished because I've now done that in that domain. Okay. So just check that you've done what you were asked to do. My amplitude is 4, so from 3 to -1, that's 4, and from -1 to 5, that's also 4. And I've also got a -1 transition, so yes, it has moved down. It's no longer touching at the zeros for the x-axis, but it's down to -1. Okay, for the function below, find A, the amplitude, and B, the period. So if I look at this graph, I can see it's a max value of 15, and it goes down to a minimum value of 5. So what I do is I find their difference, which is 10, and I divide it by 2. So the amplitude is going to be equal to 5, okay, the absolute value of 5. And the period is every time it repeats itself. So here is where it starts.